we're going to look at standard form of a quadratic function and remind you of some of the characteristics of those that you should have seen previously, and then also introduce to you how to use the calculator as a tool to find some characteristics of these. So standard form means we're looking at the function where it looks like ax squared plus bx plus c, which looks like what we have right here. Okay, and this one we're specifically asking you guys to use on the graphing calculator. There are some things that you should know how to do, but we want to make sure that you also know how to do it on the calculator. So out of this lesson, you should get both of those things. So we're going to focus on the calculator first. So we're going to go and actually type this into our calculator. And if you struggle with the graphing calculator and you're trying to use it, there are some resources on our class resource page that you can access right from our home page on Canvas. So I'm going to type this into the calculator. So here's my graphing calculator. Up at the top of the calculator are all of the graphing buttons. So I'm going to go to y equals, and it's going to give me a list. I could type in many different equations here if I wanted to. I just want to graph this one. One note about your calculator, the negative button is different from the minus button, so you will get an error if you're not using them correctly. The variable is here next to the green alpha button where it says x, t, theta, n. Those are different variables that we use in different circumstances. And then there is a squared button right next to the comma. So we have negative x squared plus 6x plus 3. Now, a couple of things about going to view the graph. Depending on if anyone's used your calculator before for graphing, go ahead and go to the zoom button up at the top before we look at the graph. And I'm going to just go zoom 6. You can see next to number 6 it says standard. So this gives me a window. It generally gives you a window that takes both of the axes, the x-axis and the y-axis, and labels them from -10 to +10 counting by 1. It's like a pretty common type of graph that we would have. You can see that this graph works pretty well for us, except for it doesn't let us see the turning point of the graph up at the top. So I'm going to show you one other thing. There's a window button up here where you can actually define what you want. So our x values are pretty good. Just to get you guys used to this, I'm actually going to change the x minimum because we don't need to see all the way over to -10. So I'm going to change that to something like -6. I'm good with the x maximum. I'm good that it's counting by ones on the x-axis. I'm fine with the y minimum. I need to make the y maximum higher than 10. I don't really know. It looked pretty close. I'm going to try 15 this time. And there are some things you're going to learn about functions and you could figure that out. Right now, this is just kind of a guess based on the visual, but you should be able to use some other tools as well. And then I'm fine with the y scale counting by ones, and then we're not going to use any of the things that are down at the bottom for right now. So now I'm going to press graph again, and we're going to notice that my graph has been adjusted a little bit, and it's now showing me the values that I wanted to see, not just the standard values from -10 to 10. Now there's a place on your note guide to take some notes about some different calculator tools that we can use to calculate different things from the graph. So what we're going to do is we're going to use those tools and figure out things like the vertex point and the intercepts on here. So the place where you can find all of these things is again in these graphing keys up at the top. And we want to do a calculation from the graph. So you can see that there's a button called trace. That button, if you push it, just puts the cursor on your graph and allows you to move. It's kind of an interesting feature, but it doesn't really give you exact points depending on like the pixels. So notice above that, there's a blue word that says calculate. So we're actually going to push the second button and then trace. And these are all the different things you can calculate. A value, which means like you put in an x and it gives you out a y. You can calculate a 0, which remember is another word for those x-intercepts. Or you can calculate a minimum or a maximum. So either of those could be a turning point of the parabola or an intersection. So if you had graphed more than one thing, it can find the place where they intersect. The two at the bottom are more calculus concepts that you'll cover at a different time. So right now I want to calculate the vertex and my parabola faced downward. So I'm going to choose choice 4, which is that maximum. And then notice it just puts me back on my graph with the cursor, but notice the calculator is asking a question. It says left bound. It wants you to take the cursor just a little bit to the left of where you consider the vertex. So maybe where I am is just fine, and I press enter. It then marks it and asks me for a right bound. So I'm going to go to the right of what I consider the vertex point and press enter. It then asks for a guess, and so I'm going to go around where I think the vertex point is and press enter. And then it's going to give me this. Now 2.99999, we can call that 3. The calculator is performing a question about like a process, a calculus process about how to estimate this. So the value is probably exactly 3. The process for the calculator is just a little bit different. So anything that has lots of 9s like that or lots of zeros after a decimal, we can round in this context. So now what we're going to do is we're going to find the intercepts or the zeros. So we're going to go back to that calculate menu. And this time I'm going to choose choice 2, which is a 0. Now there are 2 of them and it can't find both of them at the same time. It's going to go through a similar process as the vertex. So the first thing it's going to do is ask you for a left bound. So if you struggle with this, go to where you think the thing is that you want to calculate. So I'm trying to calculate this 0, the left x-intercept here, and then arrow to the left a few times, and then you'll know for sure you're to the left of that and press enter. Go back to it, and then arrow to the right a few times and press enter, and you have a good right bound. For guess, just get as close to it as you can, and then it will come up with that 0. So we have negative 0.464 as one x-intercept, and now I'm going to go and find the other x-intercept. So the same exact process. Remember, we're calculating a 0. That's the same thing as intercept. And now I need to arrow all the way over to the other side of my graph where that 0 is that I want to use. And again, I'm going to arrow to the left side of my 0, to the right side of my 0, and make a guess. And so then it came up with the second x-intercept, which we see as 6.464. So now I have both of my x-intercepts. So I'm going to return to your note guide. And so there's a place here for you to write stuff, but also write some notes for yourself. So the value we got from the calculator for the vertex was 312. And we got x-intercepts of negative 0.464 and, because there were 2 of them, 6.464. So make some notes for yourself if you need to about the keystrokes on the calculator. The axis of symmetry here needs to go through the x-coordinate of the vertex, so it would be x equals 3. The maximum value of the parabola would be the y value of the vertex, so it would be 12. This parabola faces downward, so it would not have a minimum. The domain is all real numbers for these quadratic functions, or you could write it in interval notation. And then the range, since it faced downward and hit a maximum of 12, I would know that my y values are at or below 12. Or we can write that as negative infinity to 12, making sure we're using that square bracket with 12 to emphasize that it does hit 12. All right, now we're going to do the same kind of idea, but do this by hand. You should have these skills. We're trying to teach you 2 things you should know on your own about the parabola in order to build a foundation to go a little further in your study of mathematics, and then also using the calculator as a tool. So we do recognize the tool will be used, but we also expect the user of the tool to be able to know some things and make sure that they make sense. So you should be able to do these things by hand. So now we're going to do number 4, and we're going to do it by hand. So if you guys remember from our little characteristics of Quadratic's PowerPoint, there's a formula that actually gives you the axis of symmetry, and it's based on averaging those values you would get from the quadratic formula. And it's negative b over 2a. So for this quadratic, our a is 4, our b is negative 16, and our c is 10. And so this is what we would get as we went to do this calculation. So we would end up with a positive 16 over 8, which is 2. This tells me my axis of symmetry is at 2. If the axis of symmetry is at 2, we know that our vertex has an x-coordinate of 2, and we want to find the y-coordinate. And remember, once you have an x and you have an equation and you want to find the y, you just need to take the equation and plug that x back in. So in this case, I'm going to plug 2 in for x and then be able to see the y-coordinate I would get for that vertex point. So here, I'm going to finish up this calculation. So first I'm calculating exponents, then I'm going to do the multiplication, and then the addition. And that gives me a y value of -6. So now I know that my vertex is specifically at 2, -6. So I'm going to mark that on my graph. So this is a little bit different than graphing in vertex form. In vertex form, we get a whole list of points by performing the transformations. And then for here, we get the vertex point through this calculation, but we need some points that kind of correspond with that on the side of the axis of symmetry. So we're actually going to plug in a new value of our choice. So this kind of takes us back to our roots of like plugging in to get points on a function. We know the shape. I really just need one other point on this parabola to give me a good idea of how wide or how narrow it is. So I'm going to choose an x value. I'm going to choose 0 because it's easy to plug in and it's close to the axis of symmetry. I'm going to plug in that x value of 0 and get a y value of 10, and this tells me a point on the graph, and this point happens to be the y-intercept, which is a nice point to have. And I can see that this is a really narrow parabola, but that makes sense to me because that a value is 4. That's going to cause a big vertical stretch like that. Okay, and so then we have our vertex, and our axis of symmetry was at x equals 2. So that's how we would get the same pieces of information by hand. So we're going to look at one more example that kind of puts this into context if we have this vertex form, and then we'll see the different ways we could figure this out with or without a calculator. So this gives a stock model for performance. So it tells you that D represents how many days of trading have gone on, and P is the price per share. So we can basically plug into here D, how many days it's been traded, and it should calculate for us P, the price per share for this stock. And it wants us to find the maximum price per share of the stock. So first, you need to understand shape and relationship. So see here that this is a quadratic because of the D squared, so I should automatically think parabola. Then I know the parabola faces downward because of the negative a value. So I get this picture in my head. So I want to understand what they're asking. When they're asking for the maximum price per share, that's going to occur at the vertex of the graph. So really my goal is going to be to figure out the vertex of the graph and then interpret it correctly. So we have two ways that we can go do this. We can go do this on the calculator, or we can do this here by hand. So let's say we try the calculator first. I'm going to go to the calculator and I'm going to type in this equation as y equals -3x squared plus 50x. So I'm going to go back to y equals. I'm going to clear the equation that was there, and I'm going to type in -3x squared plus 50x. Now, I'm going to hit graph, and I want you to keep in mind, this doesn't look very nice. I see a very small portion of the graph. Remember that our zoom here was zoomed specifically to that other equation, and now it doesn't fit this one very well. So I'm going to go back to zoom. I'm going to choose choice 6, the standard window, and that doesn't look much better. So this is where your knowledge of the graph and actually being able to do stuff by hand helps you be a better operator of the calculator. So when I look at this and I'm like, oh, I can't see it on the calculator, what am I going to do? Remember that this vertex point is related to your axis of symmetry, and there is a formula that tells us where that axis. So I'm going to find the axis of symmetry using that formula, negative b over 2a. That's going to give me negative 50 divided by negative 6. And when I do 50 divided by 6, I get 8.3, where the 3 is repeating, so like 8 1/3. So I know my vertex is happening at 8 1/3. So compared to my calculator window, I actually do have that point on here because it goes over to 10. But if I want 8 1/3 to be the middle, okay, because that's kind of where the axis of symmetry is happening, and I can see it's hitting at like 0 here. I want to go at least over to like 16 or 17. So I'm going to go in my window right now, and I'm going to change my x minimum. I don't need to see as much, so I'm going to change that to negative 5. But I'm going to change my x maximum to like 20. And I'm still okay with it counting by ones. Let's see how that helps our graph. All right, so now we can actually see both sides of the parabola, but we clearly can't see the vertex point, which might be hard to tell, but I know it's above because I know the shape of the graph. So I'm going back to my notes and think about how could I have any indication on my own about how high this is, and that's where plugging in this 8 1/3 would be very, very helpful. So if we want to think about this as 8 1/3, it would also be 25/3. So I basically want to do this calculation to get the y value of that vertex. So I'm going to use my calculator to do this calculation. So 25/3 and then squaring that and timesing it by negative 3 gives us like negative 208 1/3. Then we have 50 is multiplied by 25 and divided by 3, and that gives us like 416 2/3. And combined together, those give us 208 1/3, it seems. So if I were to change my graph, I want to make sure I can see that point. So I'm going to take this information back to my graph, and I'm going to go to my window, and I need to have a really high y value. So I'm going to change that y maximum to like 220. And now I probably don't want it to count by ones. Maybe I'll have it count by like tens so there aren't as many marks on the scale. Now I'm going to go back to graph, and hopefully I see a much better picture. Here we go. And then we could find that vertex. However, we technically already found the vertex here in our calculation. So you can see sometimes the calculator tool is better and sometimes our work is better. We already found the vertex here, that it has this x coordinate of 8 1/3 and this y coordinate of 208 1/3. And then understand that our x coordinate in this case is the d, or the number of days that it's been trading. And our y coordinate in this case is the p, or the price per stock. And the question was, what is the maximum price? So the maximum price that we're getting is that maximum y value, and we'll call that $208.33 in this context.